This is the third question in the Good Question series for JEE Mains and NEET. Good questions are the harder questions, and nearly 25% of the paper is good questions. Your attitude should be that you welcome these good questions. Why? Because they help you to differentiate yourself and boost your rank. So here is a good question which combines two concepts. One is collisions and the other is projectile motion. The question is, a projectile projected with a certain speed u and angle theta with the horizontal strikes the wall at a distance d away and returns to its original point after the collision. What is the coefficient of restitution when it hits the wall? Now, nothing is given in terms of the kind of path taken. I have taken a path like this. It is going upwards and it has not yet reached its full height, and then it collides with this wall. The angle of projection is theta and the speed is u. It could be something else also. For example, it could have been that it goes to its full height and then collides while coming down and then comes back and hits the original point. That is one possibility. And another one is that it hits it straight perpendicularly and comes back. But nothing is given. So what do you assume? In general, we have to assume that it is an oblique collision. It could be while going up, it is colliding, or it could be while coming down, it is colliding. In general, oblique. So before we solve this question, let's recap the oblique collision concept. Suppose there's a ground here. An object with a mass m traveling with the speed u hits it at this point such that the angle of incidence is alpha. So it bounces with a certain speed v. In general, this speed v is not the same as u, and an angle of reflection beta, which is in general not the same as alpha. In general, on what does it depend? We'll see that. So right now then, if we take this velocity v and decompose it in its horizontal and vertical components, since this is beta, this is also beta, and its component along this direction is v sine beta, and along that direction is v cos beta. This is after the collision. And before the collision, u was downwards. So if this is alpha, this is also alpha. So u cos alpha is coming down. And the horizontal component is u sine alpha. In an oblique collision, the tangential component remains unchanged. That means u sine alpha will be the same as v sine beta. So that's one equation we can write. The collision only happens along the line of impact. The line of impact is a line that is perpendicular at the point of collision and perpendicular to the surface. This is LOI, line of impact. The collision happens along that. Now, if you look at this line of impact, along this line of impact, it came down with a speed u cos alpha, and it will bounce up vertically with what speed? In general, coefficient of restitution times the speed. So therefore, v cos beta will be equal to eu cos alpha. So we have two equations here. Now we see the first equation. If somehow the speed after the collision v was equal to the initial speed, if v was equal to u, then sine alpha is equal to sine beta. That means alpha is equal to beta. So that means if beta is equal to alpha, then v must be equal to u, and that is angle of incidence is equal to angle of reflection. When does this happen? For what type of collision? If the speed after the bounce is the same, that means there is no loss of kinetic energy. That means that is a perfectly elastic collision. So here you learn something. In a perfectly elastic and oblique collision, the angle of incidence is equal to the angle of reflection. Now, v cos beta is equal to eu cos alpha. And here also, if v is equal to u, then beta will be equal to alpha. That means v cos beta is equal to u cos alpha completely, and e will become equal to 1. E equal to 1 implies perfectly elastic collision. If you divide these two equations, 1 and 2, Then V sine beta upon V cos beta is tan beta. And U sine alpha upon EU cos alpha is tan alpha upon E. Now look at this E. In general, if it is a partially elastic collision, then E will lie between 0 and 1. That means beta is more than alpha. And if the E is equal to 1, then tan beta is equal to tan alpha and alpha is equal to beta. And if E equal to 0, then what happens? That is a perfectly inelastic collision. So that means if this is 0, then this entire thing is infinity. That means beta goes to 90 degrees. Beta goes to 90 means what? That after the collision, it will slide down like this. It won't bounce at all. This is oblique collision. So here also we are having an oblique collision at this particular point. So let's draw that. So this is the point I'm talking about. It is coming here with some speed v, and this angle of incidence is alpha. Its initial components perpendicular to the wall are v cos alpha and parallel to the wall is v sine alpha. After the collision, v sine alpha component remains unchanged and the perpendicular component returns with the multiplication of E. Now, where do we go from here? We have to find the coefficient of restitution. We don't need to bother about the vertical velocity. You see, vertical velocity before the collision was v sine alpha. After the collision also it is v sine alpha. That means the vertical component never changed. And if you look at time of flight, it only depends on the vertical velocity. The time of flight is the initial vertical velocity uy upon g, or 2u sine theta upon g. Yes, there is a collision, but the vertical component is not changing at all. That means the total time to cover via path 1 and via path 2 back will be the same as though it went off like this. That is the total time of flight. That doesn't change. Now it is very easy. The time taken in the first part of the path and the time taken in the second part must be totally equal to the time of flight. In the first part, the horizontal distance is d, that is given to us, and as you know, the horizontal component of the velocity never changes while going from here to here. So the time taken is the distance divided by the horizontal speed, which was du cos theta. And the second part, the horizontal component changed. So E u cos theta, and that is equal to the total time of flight, that is 2u sin theta by g. U cos theta, here when you look at the horizontal component, that is u cos theta, and here it was v and v cos alpha, they have to be the same, right? So ev cos theta is actually u cos theta. That's what is used here. Now we have a simple equation in E. Solving, we get this answer. Beautiful question, which is integrating two separate chapters. And usually the tougher ones are those questions which have concepts drawn from more than one chapter. So practice those questions. Hope you enjoyed it. Put a like or a comment, subscribe to my channel, and wait for the next question as well.